Trigonometry, Chapter 2, Acute Angles and Right Triangles. Section 1, Trigonometric Functions of Acute Angles. Video 3, Cofunctions and Cofunction Identities. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous videos, we explored the transition from coordinate plane to right triangle trig. We also calculated the values of the trig functions in some acute angles when given two sides of a triangle. In this video, we explored the idea of a cofunction. This was briefly alluded to in a previous video. Earlier, I mentioned that we would investigate why our trig functions seem to occur in pairs, namely sine of theta and cosine of theta, secant of theta and cosecant of theta, tangent of theta and cotangent of theta. Why are three of the trig functions named the same as the three others, except with the prefix co in front of it? And the answer lies in the meaning behind that prefix. In this context, the prefix co refers to complement. For example, consider the following generic right triangle where we have a hypotenuse and two angles alpha and beta. What is the relationship between angles alpha and beta? Well, because the sum of all three angle measures was 180 degrees, and the right angle accounts for 90 degrees, the other two have a sum of 90 degrees, alpha and beta. In other words, the two non-right angles in a right triangle are complements because their sum is 90 degrees. Within a given right triangle, the adjacent and opposite relationships vary from angle to angle. For example, the side adjacent to alpha, the one highlighted in yellow, is currently the same as the side opposite of beta. And similarly, the side opposite of alpha is the same as the side adjacent to beta. So who is whom depends on the angle you're referring to. Because of this, we can say the following. Watch closely. If we did sine of alpha, it would be the side opposite of alpha over the hypotenuse. But the side opposite of alpha is also the side adjacent to beta. So if we make that switch and it's still over the hypotenuse, then this ratio is now the definition of the cosine of beta. So, since alpha and beta are complements, we can now state the following. If alpha and beta are complements, then sine of alpha equals cosine of beta. That was a result of this train of thought. So we have a complementary relationship between sine and cosine, but it goes a little bit deeper than that. The word cosine is derived from complement sine. Cosine of beta is the sine of beta's complement, or the complement sine, which is sine of alpha because that's the complement of beta. So that's why it's called cosine. It means complement sine. We can actually state this fact in reference to a single angle, say beta, since we can represent its complement as 90 degrees minus beta, since the sum is 90. So cosine of beta equals sine of alpha can become cosine of beta equals sine of 90 degrees minus beta, and now we only have to refer to a single variable. Using a similar argument, we can establish the following cofunction identities. Cosine of beta equals sine of 90 degrees minus beta. Cotangent of beta equals cotangent of beta equals tangent of 90 degrees minus beta. And cosecant of beta equals secant of 90 degrees minus beta. With cofunction identities, we can rewrite one function in terms of its cofunction. For example, we're going to write each of these functions in terms of its cofunction. Sine of 35 degrees, cotangent of 22.5 degrees, and an expression secant of 45 degrees plus theta. So how do we do this? Well, the first thing we have to do is set up the cofunction of the complement. Well, that's what we have to do, set up the cofunction of the complement. So we'll start by setting up the cofunction of each trig function. Cofunction of sine is cosine, cofunction of cotangent is tangent, cofunction of secant is cosecant. And then we're going to set up an expression to calculate the complements, which is to subtract each angle from 90 degrees. Notice in the bottom when we subtracted the 45 degrees plus theta from 90, we did have to put it in parentheses because we're subtracting. And then we just simplify. We get cosine of 55 degrees on the top, tangent of 67.5 degrees for number 2. And when we simplify this one down here, we are distributing the negative. So we have 90 minus 45 is 45, and then the theta becomes a negative. And that's pretty much all you have to do. So now you try. Pause the video and try the following. Rewrite each function in terms of its cofunction. Number 1, cosecant of 10 degrees. Number 2, cosine of 85 degrees. And number 3, tangent of theta minus 10 degrees. Pause the video, give it a try. All right, here's your fair warning if you haven't paused the video yet. Solutions in 3, 2, and 1.